where I'm talking about
Live.
being live and we're not live. Hello, everybody. If you can see me and hear me, I'm waiting to see and hear myself on YouTube to make sure
Hello.
this whole thing is
Hello.
working. If you see me, drop a hello in the chat. I don't think it's live yet, though.
It's live, Richard. It's always live.
I know, it's always live. Is it
Gotta
good?
believe.
We're getting a thumbs up. Okay, I see myself on YouTube. I can hear myself on YouTube. There we go. We are live. Hello, everybody. How's it going? Welcome to day 3, the final day, the best day. Not the penultimate day, because that would be yesterday. Everybody thinks penultimate means the last day. It's not. Look it up. The more you know. Here we are on day 3. Dave, yesterday took you through deploying a smart contract. You made it back. You persevered. You're here. Some of you are still filtering in. What's up, everybody? Hello. Hello. Today, we're going to go a bit deeper down the rabbit hole. I don't know, Dave, what do you want to say?
I just want to say it was amazing on social media yesterday, just throughout the day, throughout the evening. I tried to respond to all the ones that I saw to just see all the smart contracts getting deployed, feeling empowered. We've gotten a lot of feedback from you. Let's try our high five again. Richard, up there. Boom.
Boom, nailed it.
Boom.
Yeah, we were practicing that earlier.
Yeah,
We're nerds like that, y'all.
Yeah, it warms my heart just seeing you all build. And I know for a lot of you, this was the first time. Please don't make it a last time. That's it. I'll be off camera. I'll be around trying to answer questions. And you are in good hands with Richard.
Awesome. Yeah, so first things first, today we are going to have a special guest. We have Steven from Space and Time here. He is the head of solutions at Space and Time. I'm bringing him up in just a second, but he's going to talk to you all about Space and Time and what it is to actually create something, work at a company that's using this technology in this space. So Steven, how's it going?
Hey, good morning, good evening. How are you?
I'm doing great. It's morning here, but like if you're looking at the chat, you can see there's people from all over the place. So yeah, good time of day to you.
Yes, good day.
All of you watching.
Hey, sir.
So yeah, I guess I'll let you take it away, Steven. Let me know when you want your screen on stream, and yeah.
Yeah. Thank you. Excited to be here. Space and Time. I think we're one of the OG Chainlink build programs. Like I think we were the very first cohort to go through that. So we've been partners with Chainlink for a long time. I'll go into what we're building, and you can go ahead and throw my screen up there because I kind of like to talk through it. So Space and Time, what we've built is a decentralized database that collects different blockchains, and that's what we're seeing here. And so I assume you can see. Let's see. Yeah, there we go. Okay, so we index the different blockchains into our data warehouse, and I'm going to say data warehouse and database a little interchangeably. If you're familiar with a database, think of like Postgres or MySQL or SQL Server or things like Snowflake or BigQuery. A database, a data warehouse is really just a really big database, right? Think of it like a database that's spread over many servers. So we're actually a data warehouse in that we can do things like store lots of data. And my favorite example here, which I think is still one of the biggest, if we have it here, is our logs table. And this is for Polygon. And so this is every event from every smart contract on Polygon. And this one table is 3.5 terabytes. And so that's not uncommon when you're talking about data warehouses. So we index different blockchains, and that lets us do things like run queries that perform pretty well. Like in about 3 seconds, we can go through 190, call it around 200 gigabytes of Ethereum data, right? And we're just pulling out native wallets. So as data comes into different blockchains, we're picking up that data and we're putting it into these tables so that people can easily query it and start doing things like making graphs and dashboards. We'll look at that in just a second. But let's say SQL is not your thing. We also have an AI prompt here. So we could also say, show me the count of Ethereum wallets with a balance greater than 1 billion for last week. And let's say by day or by date. And we'll run that. And I don't know why that didn't work, but we can also put it down here. And that didn't work either. So that's not a very exciting demo. But it should actually generate some SQL. We'll come back to that in a minute. The other thing we can do, once I get my my shortcuts all sorted out here, you can also do, well, that's a more sophisticated query. We're going to leave that one alone for a second. Let's do this one. This one's kind of fun. This one's looking at the TPS of Polygon versus the TPS, or transactions per second. When I say TPS, I'm saying how many transactions have happened in 1 second. And you can see, for a particular date, for Christmas Eve last year, because we're coming up on Christmas, you can see Polygon and Aptos are about the same. We can actually just drop in here and call this one Ethereum. And I'm going to change the name over here as well to Ethereum. Ethereum, if I can type. There we go. It's a little early here. And the point of this is that we try to keep these different tables named the same, or the structure is very similar, so that if you do something for Polygon or for Aptos, especially for EVMs, Aptos, by the way, is not, it's a different type of blockchain. It's still a blockchain, but it's what they call a move chain. Just means it's not an Ethereum-based chain. But all of this, it should be very transposable. So once you kind of figure out the data model, most of them start making sense pretty quick. In fact, I could do the same thing here for, whoops. If I copy everything here, I could also add ZK Sync. We're going to copy and paste that over here so we can see it. Oh, it's a ZK Sync Era, sorry. It is ZK Sync Era, all one word. There we go. So anyway, the point is that it's very easy to do this. And we'll actually do one more thing here. There we go. So we can see how everyone's doing. And we could keep actually adding to that over and over again until we get through all of these different blockchains, which we're not going to do. But like I said, if you want to explore what's out there, you can go through. Bitcoin is obviously a little different. That's the original blockchain, so to speak. But you can drill through Sui and Aptos and ZK Sync and all these different chains. So once you generate some queries that you think are interesting, you can go back and you can do some visualizations of those queries, and you can create dashboards. Like here's a ZK Sync dashboard that shows you different characteristics, liquidity, memory. I think this is I don't know what that is. These were all created by the community, by the way. So like when we partner with different blockchains, we will go through and we'll do things like marketing campaigns to have people be able to go use the new blockchain data and generate a bunch of dashboards. So if I go search for ZK Sync, it's always fun to do these because I have no idea what's out here. People add to this all the time. Right? You can see all the different dashboards, and looks like we have 10 per page, 52 pages. So we have, 520 dashboards or thereabouts. So I don't know. Maybe we'll drop into. Let's drop into this one. I've not actually looked at this one before, but it's always fun to go kind of play around. They didn't label their charts very well, but the point here is that you can get in, you can start building analytics and views into this blockchain data very, very easily.
So, Stephen, hey, that's Richard. I see some questions in the chat, and I have questions myself.
Yeah, let's go.
Right. So a few things, just to clarify, like, again, this is like a lot of the people here super new to this space, right? So when you say something like ZK, what does that mean?
Yeah, sorry, I throw these acronyms around sometimes. I appreciate that. ZK means zero knowledge. It's a type of cryptography that allows you to basically prove something without showing what you're going to prove. And so this is a hard concept for even like people who've been in blockchain for a long time. I'll give you a real example. And by the way, one of the things that we can do in space and time is actually run ZK proof queries. So one of the things that differentiates space and time from other databases is that we have tamper-proof data. You can create a table or use our blockchain data in a tamper-proof way. And what that lets you do is connect it to a smart contract. So as you guys are learning into Web3, smart contracts are awesome. They're the foundation of so much of what's in Web3, but there are limitations. You have a little bit of data and a little bit of memory, a little bit of compute that you can use inside of that framework. If you wanted to go query 3 terabytes of log data, there's no way you could do that. And so I'll give you a practical example of things that people do. If you are building a lending protocol, it's difficult to say, the lender or the borrower wants to borrow a certain amount of assets. What's the history of their return? How often have they been liquidated in the past? What's the risk of lending that wallet, some kind of funds? That's a really hard thing to answer. In fact, really practically speaking, it's impossible to do it cost effectively. And so you need things that will operate near chain, right? Like space and time. And by the way, we have integrated into space and time things like Chainlink functions.
Yeah. So when you say near chain, like again, when you say near chain, I think what you mean there, and correct me if I'm wrong, is that, so we've talked previously in this boot camp about how the blockchain works. We've talked briefly about nodes within the blockchain and how they basically are confirming transactions on the chain. And we're paying gas because they're doing work for us. But what you're saying is the amount of work that they can do is kind of limited, right?
Correct.
So in the example, guys, when we talked about what's 1 + 1 and we all write down 1 + 1 = 2, right? If I were to ask you to solve like a really big problem and we are now all solving that problem, that takes a ton of total resource, right? So we want to be solving smaller problems since all of us have to solve it. That's kind of how I think about like a blockchain, right? And so when you say near chain, what does that mean?
Yeah, that just means that it's a system like Chainlink, like space and time. Chainlink's more of a, it's more of a well, it's an oracle, right? You guys know what oracles are.
We haven't gotten there yet.
Okay.
That's today.
That's today. Okay. It's a system that's designed to work with a blockchain without being a blockchain itself. And so space and time is like a blockchain. It's decentralized like a blockchain. And so when data comes into space and time, kind of like Richard, you were saying, all of the different nodes look at the data and say, who's loading that data and it may be encrypted, but what the value of those bits are. Think of it like a hash.
Right.
It's like
we've talked about hashes.
Okay. So yeah, it's like a little hash that we can store, and we can say that person loaded the data that matches this hash, right? So you don't have to see the data, you don't get to see what's in it, but you can see an approximation or something that you can always tie that data back to if you wanted to or needed to. But
Gotcha.
all of that happens, or a lot of that happens in a what we call DPIN, or decentralized physical infrastructure. It's like nodes that are decentralized, but they don't have the same structure as a blockchain.
Right.
And
So we're maintaining the decentralization benefit, but we're taking the hard work, the computations, moving them off. So like not everybody in the blockchain has to do them, but then you're basically putting that hash, that proof of what happened, back into the blockchain.
Right. And this, I'll warn you, it's a hard topic when you talk about things like ZK. So in the analogy where you have a blockchain, and think of like a blockchain as a group of people, and they all agree that you have this piece of paper, someone wrote a little index card, has one on it, everyone agrees, yep, okay, that's one. But then someone says, well, I need to do a calculation that we can't, like, it would be too prohibitively costly, or it's a whole page of calculations, right? Like, you don't want to tie up everybody redoing the same calculation. And so what you do instead is you say, hey, I have a buddy at a different table. I'm going to ask that person to do that calculation. And then they spend all sorts of time doing the calculation, all this effort, but they're really good at math. And so they can do it pretty quick, far faster than anybody that's holding up the cards at the primary table. And then when he gives it back to you, you have this answer. But how do you know the answer is correct? Because you still need that consensus, right? Well, it turns out that he can also give you, when you get the calculation, that they also give you the answer to the calculation. So they say, here's a calculation, you need to do that. You hand it to your buddy. He doesn't know what the answer is, but they also give you the answer. So when he hands it back to you, you don't need to understand the entire calculation. All you have to do is look at his answer and compare it to the answer that it should be. And if it works, if it's, if 1 equals 1, or 12,000 equals 12,000, then he did it right. Now everybody at the table, at the blockchain table, they can all get the same answer to the calculation, and so they can all do that comparison. Gotcha. And so at the end, you still get consensus.
Yeah.
So it's still tamper proof, because they're all saying, yep, we all agree that 12,000 equals 12,000.
Yes. So that makes sense. And then somebody's asking, for a real world application, you mentioned earlier about like if you had to look at a giant set of logs, and I know somebody was asking like, what's logs? So logs are just the log of what happened. In my brain, that was what the answer to that question was. Logs are just essentially keeping track of everything that has happened. Okay, so if you imagined that you had a car that you were driving and you wanted to log where the car went, it would basically be like, every 5 minutes you get the GPS coordinates of where the car is, and then you can create a log of that, right? For me, I don't drive a lot. I work from home. My log's going to be very small. If you take somebody who works at like DoorDash or Uber or something like that, their log is going to be massive, right? And so I think that was the point you were making too, is that sometimes there are terabytes of data, which terabytes is like a whole heck of a lot. Like it's a ton of data.
Trillion bytes. A trillion bytes.
Yeah, it is a ton of data. And asking everybody at the table, like you mentioned, to go through that data, it's not feasible, right? So then we use that near chain thing, something like space and time, to go through that data, pull out whatever you wanted to find out, right? Like maybe it was something simple like average number of miles driven per day. Pull that out, and then you can give that back and get that back on chain.
Exactly.
Okay.
In a way that you can still prove, even though the work's not done on chain. The important thing here is that you can still come to consensus on the chain, because you're giving everybody two parts. That's the answer of the calculation and what that should be in a grossly oversimplified term.
Right. And this is like to your point, this is a very hard thing to fully wrap your head around. It's like way outside. Understanding how this all works is outside the scope of this for sure. But just understanding that like there are mathematical ways to create these proofs that are like a shortcut so that you can check work without having to do the work.
Right. And the reason that's why we call it tamper proof, because if you were to change any part of the query, the question that's going in, or you were to change any part of the data that was loaded, the proof would no longer work. You would get 12 here and 13 here, and it wouldn't
Right.
it wouldn't calculate.
So-
it would not prove, wouldn't validate.
Yes. Similar, different, but similar to how like we've talked about how hashes work and how like, if you change anything in the data, the hash will be different. So it's the same type of idea, right? If something is different, then your proof doesn't work anymore.
Yeah, exactly
Okay.
right. In fact, what we load in, but like I said, when we take data and you don't get the data, but you get the hash, it's a special kind of hash, but it is a hash of the data. So very, very literally, if any byte you change, even a capital C to a lowercase c, that
Right.
changes the hash dramatically.
Yes. Yeah. We actually did that like with a tool on the first day and saw that how it can make a whole new hash, just one tiny change. Okay, cool. So now we have kind of a concept of why space and time. Can you give me an example of like what space and time? Like, we talked about like the example of like the average miles per day or something like that, but like what's an awesome, like easy to grok example of?
Yeah. I'll give you a couple really common use cases. I kind of mentioned one, which is in DeFi. If you were to go to a bank today and say, I need a loan for buying a boat.
Yeah,
whatever.
and just to clarify, DeFi is decentralized finance. I know, like, we got to get back to the very basics, right? We want to make sure everybody, it's so easy in this space to just throw around these words. But yeah, so decentralized finance. So basically, DeFi is banking on a blockchain, is how I think of it. Super simple.
Exactly.
Go ahead.
No, I appreciate that, Richard. Yeah, it's just moving money around on a blockchain, so you can borrow, you can lend, it's basically having a community of people being a bank instead of a central entity being a bank. But let's go back to real world for a second. If you wanted to buy a boat, you would go into a bank and say, I want a loan. And what they would do is go research you as a borrower and say, he pays his bills on time, he's got enough other assets, et cetera, et cetera. So yes, we think the risk of this person defaulting on that loan is low. And so they give this person a certain rate. Or they constantly miss payments and they've defaulted on other loans, in which case you're going to give them a higher rate, or they're just not going to lend to that person. DeFi doesn't have that very well today. If you're on chain and you want to borrow some Ethereum or some Link tokens to go do something, they don't have a way to determine how often you're liquidated or what kind of lender they think you are. And so just the ability to go back and do that very basic research. How many times has that person defaulted on a loan? They call it liquidated because in Web3, it's called being liquidated for technical reasons we won't get into. But maybe they have never been liquidated because they're a very responsible borrower. And so you should give them a different rate than you would give somebody who's constantly liquidated, right?
Gotcha. So you're saying, what I'm hearing is it's basically like you can use space-time to help build your own credit score, if you will, exactly. On-chain, your on-chain credit score, right?
Exactly.
Okay.
Yeah, exactly.
But that's a very hard thing to do without a tool like space-time, because doing all those calculations strictly on-chain is very challenging.
Yes, because it's a lot of data. Because you have to go through every transaction and the logs of every transaction that individual has ever done, and so
Gotcha.
it's a difficult thing. I'll give you another example, which is from the gaming industry, which is space and time. We've talked about all of the data that we load, but there's actually also data that you can load, right? Like as it's a database. So if you have tables you want to build, so if you're a video game and you want to put in-game assets like the weapons and the guns and the skins and all of the stuff inside of the game, you can tokenize that into an NFT. Have we talked about NFTs?
We're talking about those today.
Awesome.
This is a great preview for what's coming up today.
Awesome. So just think of it like it's a token, but it's a thing. You can't cut it in half and have it be worth anything, right? It's a unit,
right?
Like a weapon in a video game. And so video games can load the telemetry or the game logs. So you ran 3 steps, that's a log. You jumped in the air, that's a log. You fired at your friends, that's a log. All of this data can be put into space and time because it's just a database. And then you can join that data with the blockchain data and do things like this person, jumped in the air 5 times while wearing this particular NFT armor. We're going to give them an achievement called Frogger, maybe. And that Frogger achievement is going to be an NFT unto itself. So it's going to be like an achievement like you get on, console games or really any games now.
Yeah.
So
cool. So basically, we haven't really gotten a lot to the limitations of blockchains yet. Like we're skipping ahead for what we're talking about today a lot. But blockchains they have a lot of power, but they also have a lot of limitations, right? When it comes to like having all these different nodes reach consensus. And it sounds to me like tools like space and time give you the ability to have traditional computing power, traditional benefits of computers and all that stuff, and blockchain together. So you get like the super powered things. Now I have a question for you. We haven't talked about Chainlink yet. So we're going to talk more about this later, and I'll explain what Steven's saying here and you'll understand it. But how do you use Chainlink at space and time?
Yeah. We use it actually a couple different ways. One is that whenever you need to send data from, like, let's say you have a query you want to run and you want to put that query on chain, the answer to it. Actually, we have an example. I'm not going to go into it, but I'm just going to point at it, which is this is actually a gaming example where we use Chainlink functions to put gaming data on chain as it's collected. So,
okay.
So that's one answer. The other answer is those proofs. So we talked about the other person kind of at the other table over there doing math for us, right? When he comes back and says, I have this answer, it should be 12. Everybody on the blockchain can check it, but there's other tables as well. So Chainlink is another table that you could have check that work for you. And again, it's if everyone comes to consensus, then Chainlink, that other table, can say, hey, this has been verified. It is actually accurate.
Okay, awesome. Thanks for that. This is fantastic. I don't know where you want to go from here. Anything else you want to share? Or?
No, just it's super easy to get started. If you're familiar at all with databases, this will be very, very familiar. So in a lot of ways, we work with a lot of companies who are Web 2 companies who are getting started into Web 3 because we're kind of halfway in between both. We're a Web 2 idea, but built for a Web 3 use case. And so it's a very easy transition if you've worked in other areas and you're just getting started with blockchain and all that. It's a really easy way. And we have the UI that, again, is designed to be very easy to go through and navigate and see what's out there visually, right? So you don't have to go through and tramp. You can just say, show me everything that's got gas fees in it, and it'll pull it up. So it makes it easy to kind of look through and explore.
Yeah. Awesome. Well, I think I'm sharing the right website here. It's spaceandtime.io, right?
Correct.
If people are interested, they want to learn more. Yeah. I was never like a big database guy, like back in the day. So, this stuff It looks kind of. I did some data transformation when I worked at Fidelity, but it's bringing back memories of Informatica. I don't know if you know what that is, but anyway.
I do.
Yeah, but yeah, awesome. Well, thanks so much. I really appreciate you sharing, and to like seeing how this stuff, because in so far in this boot camp, we've just been very like conceptual, right? And to kind of put a little bit more of a flavor of like what you can actually do with this, I really appreciate that. That's super powerful and makes this seem a lot more real. Instead of just this like, hey, you can have this digital money stuff maybe and tokens, and there's gas too. So yeah, no, I really appreciate that for sure. Is there anything else you want to share or?
No, I just thanks for the time. I wish everybody good luck on their journey. It's an exciting space. It's super fun. It's really new. It changes every day. So yeah, stay plugged in with us.
Yeah, awesome. Well, thank you so much, Stephen. I appreciate you being here, and yeah, look forward to chatting again soon.
Yeah,
so I'm gonna take you off stage. All right. So yeah, thanks again, Stephen. That was awesome. Just kind of have that sense of actually doing something with this and turning it into like a real project instead of, I feel like a lot of times in these boot camps, we do a lot of conceptual demo type stuff, but seeing real projects like that is like, it's super inspiring and motivating for sure. Yeah, so we're going to change gears a little bit now. We're going back to the boot camp that we've been doing. I need to get my screen shared here and rejigger a few things real quick, rearrange back into presentation mode. Yeah. How's everybody doing? Day 3. There's like almost 400 of you here. You guys are the champions. You all, I guess I should say, are the champions. Like you're close to the finish line. We're going to talk about the certification in a minute. Today we are going to do some more hands-on, which is awesome because the first day there was no hands-on and it made me kind of sad. But today we get more hands-on, which is always fun and exciting, and hopefully things go well. Yesterday we had some road bumps, but hey, we got through it. We got there. To that note, yesterday we had the workshop faucet. We still have it today. I just added some more funds to it a little bit ago. If you did not get funds yesterday, we only need Avalanche, Fuji, AVAX funds today. So I don't know if we want to share that link, Javier, in the chat real quick for the faucet. And we can go ahead and just pop the password in there too for the faucet. If you didn't get funds yesterday, if you did get funds yesterday, remember, you don't need to get them again today. You should be good to go. All right. Today we are going to be talking about tokenization, different types of blockchains, and oracles. We're from Chainlink Labs, and we're actually going to be talking about what the heck Chainlink is. You've seen that for 3 days now. Chainlink, you're on a YouTube channel. That's Chainlink. What the heck is that? We'll talk about that here in a minute. But yeah, let's go ahead and dive in. So we're going to talk about tokenization, a couple different token standards. When I show you those slides, they're going to be scary looking. Do not worry. They're not scary. We're going to be talking about token interactions and some use cases. And I'm realizing now that I only put Fuji tokens in the faucet, and we talk about moving link tokens around. So I may take a break here in just a second and go put some link tokens in the faucet, unless somebody else can do that while I'm talking. So tokenization. What is a token? Right? That's going to be the first question. And a token is basically, I like to think of it as just a representation of a thing. So if I were to have a deed to my house, for example, right? A deed is just a piece of paper that says, this person who owns this owns the house. That's a tokenized house, right? Because that deed represents the house. A token is just a way of representing ownership of a thing. So when we talk about tokenizing an asset, it's basically just what I said. Tokenization of a house is normally done with like a deed. If you have a car, you normally have a car title, right? The car title is a tokenized version of the car. These are all in the real world. When we get to the blockchain space, you can do the same thing. If you remember, Web 1 was read only, right? Web 2, we said was read write. And Web 3, we added ownership to that, right? So we had read, write, own. That ownership piece is where tokenization comes in. It basically gives you the ability to turn something, it can be digital, it can be something in the real world, into a tokenized thing, asset, and represent that on a blockchain. Now, blockchains are really powerful because you have a way to prove that ownership, right? Yesterday with Dave, you created your wallet, and your wallet had a public-private key pair. That private key is how you can show that you own something. So that's tokenization. Things that you can tokenize from off-chain are things like, it says here we've got currency, commodities, stocks, even like real estate, art, carbon credits, right? When it comes to tokenizing currency, what that would look like is, you have, I always imagine Scrooge McDuck's vault of gold coins, right? So you have all these gold coins and you want a way to represent who owns them in the blockchain space. You can tokenize those coins, like each gold coin could have a token on the blockchain. And we'll talk a bit more about that as well. And yeah, Javier, if we can share the link to the slides too, that would be awesome. I think a few people are asking for that. So tokenization has a lot of benefits when we talk about tokenizing things in a blockchain, in a digital space, right? We have the ability to interact with them 24/7. This means anytime you want to trade things, you can trade them. With the stock market, normally it has like an open and close time, and you can only trade stocks during that time. If you had a tokenized stock, you could trade that ownership anytime. Improved accessibility, right? Something like Ethereum is available everywhere. Doesn't matter where you are. Dave was talking yesterday about how your wallet allows you to do transactions anytime, any place. Same thing goes once you have things that are tokenized. Transparency and security. You have immutable records, so you can't change them. You have transparency where everyone can see what's going on. One really cool real world example of tokenized assets is, I believe in it's California, their Department of Motor Vehicles, their DMV, is putting car titles on the blockchain, which is really cool, right? I think that's really, really cool because that is literally the example that got me interested in the blockchain space to begin with. I was reading about NFTs, and we'll talk about what those are in a moment. But I was reading about tokens that are unique, and I thought about car titles, and I think it's really cool to see that actually happening. We also get things like efficiency. We get transparency with tokenized assets. We get increased trust because you don't rely on somebody, doing what you ask. Going back to the stock trading thing, there's been examples with companies like Robinhood, for example, where trades don't happen the way that you'd think they would happen because they kind of changed the rules as they went. So you have that trust where it's, relying on trust instead of cryptography. In the blockchain space, when you're trading tokens, it's going to happen because it's based on cryptographic truths, not on trust. So this is where we're getting to the scary part. Don't worry. Don't freak out. We're going to see a lot of stuff on the screen here in a minute. Not this slide, but it's coming soon. So token standards. Essentially, tokens have standards that enable you to know what they look like, what they do, how they function. In the blockchain space, there's a few really big standards that we'll talk about. One is ERC 20. ERC stands for Ethereum Requirement Comment. Essentially, that's a standard. It defines what the thing will look like. So for an ERC 20 token, there's specific functions that are built into that token. We'll take a look at those here in a second. So an ERC 20 token is a fungible token. I haven't asked you all a question in a minute. So in the chat, let me know what is fungible. Does anybody know what fungible means? Like if I were to give you like one sentence to explain to somebody who has no idea what fungible is, how would you do that in the chat? And somebody's saying they can't hear me. Somebody's saying they can hear me. So if you can't hear me, let me know. Otherwise, I'm going to assume we're good. Okay, we've got exchangeable. I like that. I like exchangeable. Something that funges. I like this. Something that funges. Exchangeable. 1 cent equals 1 cent. Yeah. Hint: it's not a mushroom. It's really funny you said that, Darby. So I have this coin here. I don't know. Let me stop sharing. Put just me on screen for a second. I have this coin here. I don't know if we can see it. There we go. It has the yes mushrooms and the no mushrooms on it. It's my fungible token. Anyway, it's terrible. It's terrible. I'm sorry for the bad dad joke, but it's amazing. Yeah, so replaceable, right? So something that's a perfect example of a fungible token that we're all used to is just like cash in your wallet, right? Another example is divisible. That's a good example too. If I have $100, I can divide it, right? I like to think of it like this. If it's fungible, I care about how many I have. I don't care about which ones, right? This is how I think about it, right? So money is a good example of this. I don't care about which dollar bills I have. I care about how many dollar bills I have. If I trade you dollar bills, that's fine. Non-fungible, it's basically the opposite. We have things that we care about which one we have, not necessarily how many, right? If I said, hey, I'm going to make artwork and it's going to be fungible, and that'd be great, right? So you have a Picasso, I have my stick figure drawing, and we can just trade them. And that'll be great, right? Because art should be fungible. No, right? We don't care about how many pieces of art we have. We care about which pieces of art we have. So fungible tokens, ERC20s are a type of fungible token. And ERC 721, that's non-fungible. We also have Ethereum improvement proposals, and these are going to be things that are actually changed within Ethereum itself. So we have ERCs and EIPs. So EIPs affect the blockchain is kind of how I think about it. And ERCs are how you interact with things on the blockchain. That's kind of how I think about these two things. It's a very high level. Let me know in the chat, like if I'm say something and it doesn't make sense. But we'll go on to what might be the scary screen here. It's the next one. That's this one. Look at that. Woof. Okay, so fungible and non-fungible tokens. We talked about these already. We have ERC20s and ERC 721s. These are normally called tokens or coins. People will call them that, ERC20s. ERC 721s are things like NFTs. NFTs is a fancy way of saying non-fungible token. So NFTs are ERC 721s. They're unique. ERC20s, they're all basically the same. Cool. So let's take a look at what ERC20s actually look like. So this is what, when we talk about an ERC being a standard, an ERC20 token needs to have all of these different things in order to be an ERC20. So when we have a token, it's going to need to know like the total supply of that token, right? How many of these tokens exist? This is important. What the balance of a certain address is. So when we say address, remember that is in MetaMask, you have your wallet address. That's going to be what we're talking about here when we say balance of. We have the ability to transfer tokens, right? I can send you tokens, you can send me tokens. We have the ability to approve spending. This one's really, really important to understand. And I'm going to take a drink here and then we're going to talk about this. So this approval piece is something that's really important to be aware of. When we have an ERC20 token, right? Say you have something like USDC. It's a representation of USD dollars. And one USDC token equals one actual dollar. You can approve someone else to spend or transfer that token on behalf of the owner, on your behalf. So kind of like we were talking about private keys, how those are very sensitive, and you want to make sure that no one gets your private keys. You want to be very careful if you're approving someone else to spend your money, right? It'd be like I mean, it'd be great for me, but if you came along and you're like, hey, Richard, sure, you can have access to my bank account. Sign those checks away. Here's my credit card information. Go wild. That's what happens when you approve access to someone else. So you need to make sure that if you do that, it's only to parties that you trust completely. Allowance will return how many tokens you're allowed to spend. So you can put an allowance on that approval amount, right? This is also important. And then transfer from allows token transfers from one account to another. So these are different functions, different abilities that an ERC20 contract has to have. It also has to be able to emit events. When we were talking with Stephen, we talked about logs, right? Like keeping track of things. And events are essentially the blockchain version of logs. So it keeps track of what has happened. So events that you need to be able to emit are transfer. So when you transfer tokens between them, you need to emit that event. Also approval. So when you give somebody approval, approve access via the approve function. Cool. So similarly to an ERC20, we have an ERC 721. Remember, ERC 20 is the fungible token. ERC 721 is non-fungible, meaning it's unique, right? But you will notice there's a lot of similarity here, right? We have balance of, returns how many a given address is. Remember, address is your address, like your wallet address. It's your identifying who's the owner of. And this is where we start to get different than an ERC20, right? Who's the owner of a specific token ID? So ERC20s, maybe this is a bad example now with money because money has serial numbers, but imagine money doesn't have serial numbers, at least here in the United States, bills have serial numbers. Maybe coins is a better example, right? So you have a whole bunch of quarters, I don't know, dollar coins, whatever. There's no way of identifying which one's which, right? You just know how many. And in a ERC 721, you need to be able to identify which one, right? So that's where we have a token ID now becomes important. Somebody's asking how it got the name 721. I think that's just numerically where it is in line of changes and stuff like that. If somebody has, I honestly don't know other than that, if my understanding's wrong. If you know, drop it in the chat. If you have a good explanation that's 721 versus 20, where those numbers come from. But I'm pretty sure it's just, which one they are. So this is the 721st ERC. We have the ability to transfer. We have one called Safe Transfer. And basically that ensures that the person you're sending it to can actually receive it. So it's a little bit safer. One thing to note too, I always think about the blockchain and it reminds me of Uncle Ben from Spider-Man. Great power comes great responsibility. When you tell the blockchain to do something, it's going to be like, sure thing, boss, I'm on it. I'm going to do it. And so if you tell the blockchain to send something to the wrong place, it's going to go, cool, I sent it, and there's no take backsies, right? So safe transfer, make sure that you're actually sending it to something that can receive it. Transfer is just we're sending it. Niels, I love the fact that you asked ChatGPT and that the robot overlords agree that it's just a sequential number. So yeah, that's where it comes from. It's nothing fancy, but yeah. We have approve, get approved, and then set approval for all. So again, we're setting approval to do transfers from another address to transfer on your behalf. Events, we have the transfer, approval, and approval for all. So again, these are things that can be emitted. So if you call the transfer function within an ERC 721, it will emit a transfer event. Cool. So token interactions. At this point, we're going to need some link tokens. So if you don't have link, I'll go ahead and fund the faucet real quick. It's going to take me just a minute to go do it. Or I think somebody said they were going to do it. Let me check the faucet and make sure we have funds in the faucet. Because if you do not have link tokens, you'll need them for this section. it looks like we don't. So give me 1 second here. I will send some tokens over to the faucet. I'm on Avalanche. Put the faucet address in there. How many of you are there? It's about 400 of you. Cool. So there should be a link in the faucet if you need that. The workshop faucet address is in the chat above, but we will be taking a look at how to send tokens. So yesterday we had 2 wallets that we created, right? And we sent some funds back and forth. The native token, this is basically just doing the same thing with our tokens. And yes, I know I have a ridiculous amount of tokens in this wallet. It's because I've been funding the faucet. So we'll take a look here. I have 72 link in my main account. If I go to account 1, I actually don't have any link at all in account 1, right? So if I copy this, we're kind of following along here. So we've imported our tokens yesterday, so we can skip that step. So now we can see our link, right? Is anybody not import their tokens yesterday? I can show you how to do that if we need to, but I think we should be good because we did this all yesterday. I'm gonna assume we're good because nobody's screaming in the chat. Cool. Okay, so we've got our link tokens imported and we want to send them across. Lost my mouse. So we copy our address, right? This is our address here. And this is basically the same thing we did yesterday. We'll go to our other account. We'll say send. We'll say we want to send it to our account. And what do we want to send? So I'm on Fuji. If this says ETH, that means you're on Sepolia. As long as you have link tokens, that's cool. So I'm gonna pick the link token here. And we can go ahead and just send across, I don't know, 2 link? Or not 2 link? That's the question. We'll click confirm. And yeah, so this has sent link across. If we go and look at the other accounts, back to tokens, maybe I need to import it on this one too. Probably do. Well, we'll go do that real quick then. We'll go to our docs page here. Yeah, somebody else needs to import. Cool. There's the link for y'all. So it depends on what chain you're on. That's going to be the only tricky part here. So I'm using Avalanche Fuji. So over here on the right-hand side, I'll search for Avalanche Fuji. It'll scroll down. We'll say add to wallet. Just make sure you're on the right account when you add to your wallet. And we'll add tokens. And evidently, I already had a lot of link in this wallet too. But we can look here and see. So we have 47. We'll do it again just to make sure that everything's working. So we had 47. So we'll say to account 1, I want to send 3 link just to make it a nice round number now. Continue. And confirm. Sepolia would be the same thing. Yeah, if you're sending the link token on Sepolia, that would be the exact same thing as well. So you see here, it's sending link. It's been, somebody asked this question yesterday about what the speed up button does. And I don't think we answered that question. So what this does is basically it resubmits your transaction with more gas. You're basically paying a premium to encourage the nodes within the network to take your bit of work first, basically. Okay, so we sent 3 link. If I go to my other account now and I look at my tokens, you can see, yeah, it's a nice round 250. So it was up from 47. So what do we do, right? We sent link. Link is Similar to an ERC20 token. We won't get into the differences here, but for the purpose of this, it's like an ERC20 token. So we called this transfer function, right? And through MetaMask, what I did is I said, hey, this is the address of the recipient. It's my other wallet, and how many I wanted to send, right? And so I called this function and sent that out. Also, it would then emit an event for that transfer event, right? So that's pretty cool. We actually interacted with the contract all through MetaMask on the front end. Pretty cool. So we interacted with an ERC20 style token using MetaMask. Who wants to mess with some NFTs? Right? I think that'd be pretty cool. So we have here, this is deployed on 2 different networks. If you are looking at this on your own and you want to use Sepolia, you can use the Sepolia link here. I'm going to paste the link. Hold on. I'm going to paste this link into the chat so you all can interact with this contract on Fuji. So this is an NFT contract. I deployed this using Remix, like what we did yesterday with the very simple version. You can see it looks the same. I literally did the same thing y'all did. It's just my code was a little bit more complex than y'all's. Wasn't super crazy. If you want, we can talk through this real quick and I can explain what's going on. Maybe I'll do that just at a very, very high level. We have the similar things, right, where we have, looks the same, right? We have our Solidity version, stuff like that. We're getting a bunch of other contracts. That's what's happening here in this import statements. So we're pulling from a set of contracts created by OpenZeppelin. They're essentially a standard in this space. And they have a bunch of contracts, one for an ERC 721. So that's an NFT contracts, right? We have a counter contract and then a base 64. Base 64 is a way of encoding information. So we create a contract that's called Chainlink NFT. I'm going to skip over and simplify what's going on here, right? But essentially, we have Chainlink NFT. We have a string that's called Chainlink logo. I'll explain what that is in a minute, how that gets created, but it's a string, kind of like the string that we saved yesterday. We have a counter, just to keep track of our token IDs. You remember, NFTs require that you have a unique ID associated with them, right? So this is how we're incrementing that ID. Every time somebody mints an NFT, it increases the ID. Starts at 0, goes on from there. When we create this contract, this thing called the constructor runs. And what that does is just kind of set up everything. So in this case, it creates the string that goes in the Chainlink logo. It's an SVG, which stands for, is it scalar or scalable? It's vector graphic. Basically, it's a way of defining images in math. That's what this path thing is here. And we'll see what this looks like in a minute. But essentially, if you remember back to school, when you had to use like a graphing calculator, this is essentially defining points on a graph and mapping them out. We have a mint function, which allows us to create new tokens. And then we have a function to update the metadata within the NFT. You don't need to worry about this, but this basically just gives all the information behind the NFT. Cool. So super fast, super high level. What is this thing? So this is deployed at that link that I just sent. If you go to that link, you'll see you can go contract. You can look at the contract. This is what we just looked at, right? This is exactly what we just looked at. You'll also notice it has all this other stuff in here, all these other files that you could look at. These are all the things that are imported. So when we have these import statements, they pull in all this other information over here. It's pretty cool. But we don't necessarily care about all that, right? We want to mess with the NFT. So we'll go to write contract, and my wallet is already connected. So let me disconnect this. Cool. So you go to write contract, and what you want to do is you want to go to mint. And then you need to put your address in here. So we'll go up here. We'll go and grab our address. So remember, you click on the little fox, you go and copy your address. We'll paste it in here. and we'll click write. And this is a different Connect wallet experience, right? We'll use MetaMask. We'll connect our account. Again, this just kind of gives you some information on what you're giving it permission to do. So it can see our address, our account balance, activity, and suggest transactions to approve. Seems all right. We'll confirm. And then the way that Avalanche Snowtrace verifies you is it has you sign a message. And I think this is a really cool example just to share, because when we talked about those examples with the keys, right? Remember we had Bob and Alice, and Dave wanted to change it to Richard and Dave. You know, we turned it to Bill and Ted and have an excellent adventure. But we have Bob and Alice. And Bob can sign a message and send that signature to Alice with his private key. And she can use the public key to verify that signature. That's what's happening here. So when you have your private key, you can sign it. It creates like a hash. Only you can create that hash. Then Avalanche can verify that, hey, that was you that created that hash, because they have the message and your public key. So with those two things, they can use the signature that you created to verify you. And that's what's going to happen here. So when you click sign message, it's going to give you a message to sign. What you're signing is this crazy number here, this nonce. So you sign that and it verifies, yes, you're the person who controls this account. You should now see connected here, right? So what I did, I went to contract with the green check mark. I clicked on write contract. I went to number 2, mint. I copied my address, pasted it in here. When I clicked write, it prompted me to connect my wallet. I did that by signing. And now I click write. It'll prompt me to actually interact with this contract. I'll confirm. And we'll wait for the blockchain to do its magic. Somebody's asking, where is the contract? It is here. Paste it into the chat again for y'all. I think this is going to take you right to the right page. Cool. So we did that. We can view our transaction if we want. Right here, we can see our transactions done, but this is all that information, right? We can see this is my wallet's address. I interacted with it. I got token ID number 11. That's pretty cool. If we go up here, we can also see the mint is confirmed and done. Cool. So if you're following along, you have minted an NFT now. But where do we see this NFT, right? Like normally NFTs are represented by images, but they don't have to be. Any token that's not fungible could be an NFT. Normally they represent images. So we can go check out this NFT though. So if we go to this website, testnets.opensea.io. Yeah, somebody's asking, how can we view the NFT? That's what we're doing now. So OpenSea is probably the biggest NFT marketplace for buying, selling NFTs. It's also a great way to look at NFTs. We're going to the testnets version because remember, we are on a testnet. We're not on mainnet, we're on a testnet. So we'll go to testnets.opensea.io. And again, I've already connected my wallet to this site. So I'm going to disconnect it real quick so I can play along with you. So we're here. You should see up in the top right-hand corner this login button. If we click on that, we'll click MetaMask. We'll connect our account. And they're going to do the same thing where they're going to ask you to sign something, I think. Oh, maybe not. Cool. It's connected. So we connect our wallet here. And then if we click on our little profile icon, we should be able to see our NFT. And sometimes it does take a second to show up, right? And I have a lot of stuff in my wallet because, like, you know, we've been messing around a lot on this wallet. But what you all are looking for is this right here. You might recognize that little logo. It's a nice little hexagon. Hexagon is the bestagon. Number five. Who has the lowest number? I'm curious. Who has the lowest number? How can you see your number? If you go in here, let's see. I'm number 11. It says it up there. It should say it somewhere else on here too. Details, I think. Yeah, if you click on details, you can see your token ID. Right, so I got number 11. That means a lot of you were in there doing it before that. I'm curious, anybody beat number 5? Anybody beat number 5? Number 6. Oh, we're close. We're close. 27. If you go and look at the entire collection here, you can see everybody's hexagons. Man, look at all these. That's pretty cool. That's pretty cool. How many do we have total? Oh, they're not in order. They're not in order. 13. I saw, Jonathan, this is yours right here. Awesome. Number 3. Oh man, I think that might be the winner. I know number 1 was me, and then I think I minted 1, and so that was number 2. So I think we have a winner for lowest here. But if you didn't follow along, like, it's pretty easy, right? And it's pretty cool. So yesterday you deployed a smart contract, interacted with it, you created a wallet. Like, that's pretty cool. Today you interacted with an NFT. You can do things with these NFTs too, right? So right here in OpenSea, I'll go back to mine real quick. You can send them, right? If you click on this little thing, that would call the transfer function, right? So you could send it to another wallet if you wanted. I will warn you, there's this little trash can icon, right? And when you click it, it fills in the address with deed. It's deed. If you send something to this address, it's gone. It's called burning, right? Like it destroys it. It's gone. This address doesn't really exist. If you're familiar with the concept on a computer of like dev null, it's a place that exists, but it's like the nothingness. It's the void. So you can do that. You can transfer stuff to the void and it will never return. 35. Okay, we got some pretty high numbers there. There's 364 of you watching right now. Let's get those numbers up, y'all. Let's get those numbers up. I want like, at least 100 NFTs in this collection by the time we're done. So don't send number 3 to the dead contract. Don't do it. Don't do it. But yeah, you can send NFTs around. You can call all of those different functions on the NFT because we know that it is a standard, right? So the NFT that we're interacting with has all of these different functions available to it. That's how like we can see who's the owner of all of them, right? OpenSea is essentially giving you a shortcut into all of these different functions, right? Tells you who's the owner of. If we go back and we take a look at number 3 here, right? I'm gonna out you, sir, and see that we can see your wallet right here. We can see what else you've done with NFTs because it's all public information, right? 49, yes, we're getting those numbers up. I like it. Come on, we can keep going. We can keep going. So yeah, we can see the wallet address of who minted number 3, right? All that information is here. And OpenSea is giving us a really nice front end to all of these different functions that are built into our ERC 721. I think that's really cool. That's really powerful. So yeah, we've messed with ERC20 tokens. We've messed with ERC 721 tokens. We have kind of an idea of how they work, right? Is there any questions before we go in any further? Okay. So we'll talk about token use cases a little bit. We kind of talked about this when we were talking about what tokens are. One more NFT. So if you want to see how to make the NFT, just back it up just a little bit, right? Like, that's a nice thing about this. You can rewatch me. Like, I'll repeat myself infinite times with infinite patience, only on YouTube. Okay, cool. So fungible tokens, use cases. Fungible tokens, ERC20s, right? Real world asset tokenization. So you can tokenize real world things with fungible tokens, right? And you want to make sure that you're tokenizing them correctly. So examples here, things that we're talking about is like currency, right? Commodities, things that are quantity-based, not individual item-based, right? That's fungible tokens. Digital assets for tokenizing pieces of ownership, stuff like that. In-game assets. There's another example where things like gold in a game, that could be a fungible token, right? Some weapons could be a fungible token. If you had a weapon in a game like a sword. It's just a normal sword or a normal hammer, right? In a game, I imagine I think of good old Thor, right? And just a normal Viking hammer, fungible token. If we're talking about Mjolnir, Thor's specific hammer, now maybe we're talking about a non-fungible token, right? And that's kind of the difference you have to think in your mind. If you think how many fungible, which one non-fungible. Just trying to drive that home. We also have the concept of stable coins. I kind of hinted at this earlier when I mentioned USDC. Stable coins are a great tool for bringing stable assets into the blockchain space. I'm assuming you're here, you're a little bit aware of the blockchain space. You've probably heard about different coins and how today the value of even something like Bitcoin, value of Bitcoin's super high, the value of Bitcoin's super low, right? They're not very stable. They bounce around all over the place. Recently, he's been back in the news. The guy who paid something ridiculous like 10,000 Bitcoins for a Domino's pizza back in the day, right? Like the valuation of those Bitcoins has drastically changed. That was a very expensive Domino's pizza now. But stablecoins are tied to an asset like USD, so the dollar in the United States. And they're normally tied in a 1-to-1 ratio. So one stablecoin equals $1. They do fluctuate a teensy bit, right? But they're basically at 1-to-1 all the time. There's different coins that have different ways of ensuring that they're always tied to the same value. But stablecoins are a way to create an asset that is more reliable and stable. When we talk about NFTs, right? We talked about the art being an NFT. I think we mentioned that, right? So you could have that. You could have a community, and people who own the NFT are part of that community, right? You can use them as a proof of attendance. There's a thing called a POAP, proof of attendance protocol, similar to what we just did, right? Those of you who are minting that NFT, you now have a immutable record that you were here in this class and you minted that NFT, right? That's pretty cool. You can have this as a resume of sorts of things that you've done. You can use NFTs as assets if they have value. And again, you can use them as membership as well. So they're pretty powerful to have these tokens that give you access to all of these different things. Somebody's asking what's the difference between USDC and USDT. They're created by two different companies, would be the main difference. They're both pegged to the dollar in a 1-to-1 ratio. So kind of the how they're created is slightly different, but it's probably outside the scope of this. I don't want to take us down too much of a rabbit hole. But yeah, if you just look them up, you can find out how they stay pegged to the dollar in that 1-to-1 ratio, and that's gonna be their main difference. All right, so we've talked about tokenization. Cool. We've been going for an hour and 15 minutes. We got 45 minutes left. I think we're doing good on time. We're gonna talk about layer 2s, different blockchains. We're gonna figure out what the heck the Oracle thing is and what Chainlink is. And then we're gonna go a little bit deeper into one of the Chainlink products, talking about interoperability and a use case for that product. Cool. So layer 2s and other blockchains. We've kind of already had a bit of a preview of this when we've been talking about Avalanche Fuji. We've heard during the space and time thing about some ZK chains as well. So blockchains have this thing called the trilemma, right? And, I like to think of this as there's 3 different things that we care about in blockchains, right? We care about security, what we do to prevent people from having fraudulent transactions. We care about scalability, number of transactions that it can handle without slowing down. We saw this as a real problem yesterday, right? We saw a scalability problem yesterday. We maxed out the number of transactions that Sepolia could take when we were all hitting the faucet, right? So that was part of the scalability problem. And then we have decentralization. which is ensuring that, we're as decentralized as possible. If you're all the way over here, you're like ultra decentralized. Anyone can join the network and participate. No one entity controls the network. Yes, you can mint your NFT later too if you're doing that. Like that will be there forever because it's on the blockchain. So this blockchain trilemma, the way I like to think about it is it's kind of like you're the mouse pointer here, right? You can pick what you want to maximize, right? So say that you really care about scalability. Well, you can move your little mouse pointer up here, right? And say, we're all about scalability. But if you're all about scalability, are you getting any security or decentralization? Probably not, right? If we care a little bit more about security and scalability, well, then maybe that looks like you're extremely centralized, but you're now very scalable. You can have tons of transactions and you're very secure, right? So this is the problem. You can't have all three, right? If you want extremely secure and extremely decentralized, well, then you're going to end up not being very scalable. All right, so this is the blockchain trilemma. You can kind of maximize one or maximize two at the cost of the others, right? So this is how I think about it. It's like you have this little dot that you can move around in here depending on which of these three aspects you want. Different blockchains do this in different ways. So like we saw yesterday, we ran into the scalability issue, and that's because Ethereum focuses pretty hard on decentralization and security. So this is where layer 2s and sidechains come in. So Ethereum is very focused on security features. It's also very focused on decentralization. And that comes with a trade-off of speed and number of transactions, right? So that comes at a trade-off of scaling, right? So that's like we said, right? We care about security and decentralization. We're going to be less speed. So we have this concept of layer 2s. Ethereum being layer 1, the base layer, a layer 2 is built on top of it, right? So in the Ethereum context, it's basically another framework, another protocol, another chain that is built on top of Ethereum to improve either the scalability, the efficiency, or the speed. And it's not necessarily separate because all those transactions can come back to Ethereum, but it's in addition to. And it's kind of a hard concept to understand, but basically, we were talking about the tables earlier and with space and time. And it's kind of like that. It's a different table that then when it gets done, it will give its answers back to Ethereum, right? That's a layer 2. So it always can go back to Ethereum if it's a layer 2, but it has different trade-offs that it's choosing to have at the time. Sidechain is different in that it's completely separate. So it doesn't go back onto Ethereum. It's a separate chain altogether. So hopefully that makes sense. So Avalanche, for example, is a separate chain. It's a sidechain as compared to Ethereum. Now you notice that like Avalanche, you may have noticed, is a little bit faster than Sepolia. When we're messing with Fuji, it's faster. It has a different, what is called consensus mechanism, how all the nodes reach agreement. Its consensus mechanism is different. And that's what gives it the speed that is different than Sepolia. So I've got a bunch of questions here. I'm gonna scroll back to the chat real quick. I think y'all are doing a great job of kind of talking amongst yourselves too and answering questions, which is fantastic. Well, it looks like we're up to 53 at least. And if we're still having issues with the faucet, I'll check it out after this and see what's going on. Do know that yesterday when it said it wasn't working, that it did work. It was just being really slow. There's a question here, which is better, Optimism or ZK? That is a tricky question to answer because it depends on better for what. So a lot of these are going to be use case and security tolerance specific, right? So like if you are okay with less security, one chain might be better. If you really care about just speed, that could determine which one. It really, really depends on what you're looking for in your chain as far as in that triangle, right? Going back to the triangle here. It's going to depend on which one's best. There's no answer to which chain is best because you have to ask the question, which chain is best for this specific case? Okay, so that's kind of briefly touching on layer 2s and side chains. Are there any L2s on AVAX? Not that I'm aware of. I'm not going to answer as a affirmative no. I don't think so. I mean, I guess there could be. It's possible there could be. I don't think there are. People asking, I don't know, Javier, if you can pop in the link for the contract. I can do that real quick. Let's do that real quick. I hate to see people asking for something and not have it if they want to participate along. Is this the right one? No, this is not the right one. This is the right one. Okay, so here's the contract for y'all. Okay, so now we're going to talk about what oracles are and what Chainlink is. So finally, after all of this, we can find out why the heck you're on this YouTube channel called Chainlink, because what is it? So, smart contracts are amazing. They're powerful. Hopefully you agree now. You've seen some of the things they're capable of. You understand, about cryptographic truth versus trust-based things, why smart contracts are amazing. I normally in presentations put a picture in here of one of my favorite Disney movies. We'll see if y'all can picture it in your mind. If you've seen Aladdin by Disney, the animated version with Genie voiced by Robin Williams, you'll remember he's talking about his little genie lamp and the fact that as a genie, he has phenomenal cosmic power, and he also has a
itty-bitty living space.
So that itty-bitty living space is his limitation. Smart contracts, they have a limitation. They have to reach consensus. We kind of hinted at this when we were talking about deterministic versus non-deterministic things, right? We said 1 + 1, 2. We all agree. We agreed, back on Monday that 1 + 1 was 2. Cool. When I asked the question on Monday, what's the current temperature? My answer to that was it was about like 70 degrees Fahrenheit outside. Right now, I can't even agree with myself. It's 52 degrees outside, right? So I can't even reach consensus on the question of what's the current temperature when I ask myself that question twice. It's kind of embarrassing, y'all. That's because it's a non-deterministic question. And blockchains, they have to have deterministic questions because they all have to reach agreement, right? And that is the big limitation of smart contracts and blockchains. And unfortunately, as we see here, the real world is full of non-deterministic data, right? We have things like, what's the current temperature? What's the current score in a basketball game? Thinking about space and time, looking at a log, right? If we were talking about that Uber driver, well, you know what? That Uber driver is probably driven since we talked about it. All of this real world events and data is non-deterministic. How the heck do we get all the different nodes? So we see all these nodes here, right? How do we get them to all agree that something is the same, right? How do we reach consensus? And that is the big problem, bringing real world data into a blockchain. So this is called the Oracle problem. I do find it, man, that's cold, 4 degrees Celsius. I do find it ironic that we call it the Oracle problem, and the solution to that problem is oracles. We talked about deterministic, non-deterministic data, right? So we've got all these different things. We've got all the sorts of different market data, event data, payments. And oracles are the solution to the Oracle problem. So oracles, what they do is they allow you to bring that real world data into the blockchain space. And I like to think about it like this. It can make sense on a global scale, but it makes more sense in my brain if I ask this question on just like my house, right? If I say, what's the current temperature in my house. Okay, so I have a couple rooms in my house. I have a thermometer in each of those rooms. Unfortunately for me, the room I'm in now is going to be warmer than the rest of the rooms because, I'm full of hot air and I've been talking for a while. And so even then, when I ask that question, all the different thermometers are going to report different answers, right? Non-deterministic data, still a problem. If I ask the question slightly differently, but the same question, and I say, right now, at, 10:25, what is the median temperature in my house? And all those thermometers report back their answer. This is what the temperature is. Now, this is a deterministic question, right? It's a little bit harder math problem than 1 + 1. But if I say, what's the median, what's the middle value of the response from these 3 different thermometers at a given time, right? So I'm basically saying, what's the median value of these 3 numbers? Well, now that's a deterministic question, right? We've taken something non-deterministic and we've made it deterministic. And that's essentially how oracles in the blockchain work. They take non-deterministic things and turn them into a deterministic question. So an oracle is any device that interacts with off-chain stuff and provides that data for smart contracts. So data sources for these different oracles could be anything, right? We're talking about sports, we're talking about financial information, all the examples we gave just a moment ago. So somebody's saying an average, and I did say median and not average. And the reason for that, the middle number, is to ensure that you're getting the most accurate data possible. I'll talk about this in a second, though. So we have oracles. They bring off-chain data on-chain. I could have an oracle server sitting here, right? A server that brings that off-chain data on-chain, and it would work. And in a smart contract, it would be a valid way of bringing information on-chain. Now, blockchains and smart contracts, one of the big benefits is the decentralization, right? If you think back to that trilemma, we have decentralization as being one of the things. Sometimes we care about it more than other times, but within this space, it's important to have that decentralization. So if I have a single node here, is that going to help that decentralization, or am I centralizing everything? Right? If that node goes down, I'm out of luck. If that node decides to tell me that my house is always 100 degrees Fahrenheit, hopefully not Celsius, so that'd be real bad, 100 degrees Fahrenheit, do I have any way of disputing that? Because that's the only source of information, right? So we have centralization if we have one node. So this is where Chainlink does things differently. It's not just one node, but it's a distributed oracle network. So it's a bunch of nodes, similar to how a blockchain is set up, right? So all these different nodes, they have to reach consensus. So we have a real world data. We have the Chainlink network. We have all these different nodes, right? And they can send their information to the blockchain. They reach consensus, like I mentioned earlier. They each go and check. If I say, what is the current score in the basketball game? Each of the different nodes will go and check. They'll all report back, and they'll come to consensus on what the median value is of all their answers. Now, the reason median is important and not average, right? If I say the basketball game scores are 10, 11, and 12, right? So the median score is going to be 11, that middle number. If I said the average, in that example, it still comes out to 11, right? But now I have one really bad node who's like, no, there was money on the line for this game, and I need that score to be a little higher. And so if we take average score, all it takes is that one node to go, yeah, the score is 10, 11, and 10 billion, right? Suddenly our average number is like through the roof. The median number is still 11, right? So this is kind of why we say median instead of average, and why we use that, because it just makes ensuring that the data is most valid as possible. So yeah, there's a couple questions here. Y'all are writing like books of questions. This is awesome. Suppose we have a smart contract for house insurance. Suppose this one of the houses gets burned. In this case, well, you can provide data to the oracle. How will other node? I'm not sure about this house insurance question. I'm sorry. The right source for the data. So how do we identify the sources? So That's kind of a complex question, but basically, if you have a distributed network with a lot of different people and they all are looking at their own sources, then when you reach consensus, you're probably going to have the most accurate thing, right? If everybody is looking at the same source of data, you're going to end up with that centralization again. And then the consensus model, that's a little outside the scope of this. If you look at our docs, we have a white paper where we talk about how we reach consensus. So if you go to docs.chain.link, you can find that in there. Cool. And then is there a minimum number of Oracle nodes for consensus? Yes, depending on what we're doing, the minimum number can change. And if we have time towards the end, I'll show you about that as well, where to see that. So this is what Chainlink is, right? We're this distributed Oracle network. And we have all of these different products that create like a platform for smart contracts. I saw somebody ask something about random numbers, right? Like we can do that. Random numbers are really hard in the blockchain space, right? I'm just going to take the top 2 people to answer this question, but give me a random number between 1 and 1,000. Just pop it in the chat. We'll see if we can reach consensus. If this works out and y'all give me the same number, I would be amazed. Javier. Cool. So we have 777, we have 1. Man, look at that. Y'all are just not good at reaching consensus on this random number business, right? Like it's really hard for everybody to agree on what the random number was. It was 42. So the random number was 42, but like y'all did a fantastic job trying, right? So random numbers are really hard in the blockchain space because we all have to reach consensus. Chainlink helps with that. Like within the Oracle network, we have a way of creating random numbers and bringing them on chain with a mathematical proof showing that they're random, right? Stuff like that is very challenging. So we have Chainlink. It's a distributed Oracle network. We have our nodes that kind of mirror a blockchain. We bring that information into smart contracts on the blockchain. Chainlink is the standard for Oracle stuff like this, bringing off-chain information on-chain in a secure fashion. We have all sorts of things. We have data feeds, which allow you to bring price asset paired data on-chain. That's a fancy way of saying like what the value is of a thing. So, if you wanted like the cost of 1 ETH in terms of USD, that would be data feeds. Data streams is basically the same thing. It's just set up a little differently. Data feeds pushes that information on chain at regular intervals. Data streams lets you get that information and pull it on chain whenever you want. We have Chainlink functions. Stephen mentioned Chainlink functions very briefly when he was talking about space and time. What Chainlink functions does is lets you run complex computations and JavaScript code for your smart contracts, but outside of your smart contract. This is when he called it near chain. Essentially, it lets you, query APIs. So APIs are a way for computer programs to talk to each other. Essentially, a great example of an API is if you pull up social media on your phone, and like it refreshes, what your phone is doing is it's talking to an API on the social media servers and getting back that information, right? So that's like a pretty common API that people use. Functions let you do that. It also lets you run complex mathematical computations off-chain to save you gas. Because remember, when you're doing hard work on the blockchain, you have to pay the nodes to do that hard work. We have automation as well, which allows you to create either time-based or event-based triggers for smart contracts. So when we are looking at something like this, right, and we have all these different functions in here, the smart contract for the NFT, super powerful, right? Is it going to do anything by itself, though? No, it's not, right? It's just going to sit there and wait for you to do something. If you want it to mint, you have to come in here and you have to say, hey, mint it, So the smart contract's exceptionally powerful, kind of lazy. Automation kind of gives them that motivation of like, hey, go do something. And it'll do that. We have proof of reserve, which allows you to ensure that there are assets to back up tokens, right? So a proof of the reserve that's behind it. We have VRF, which is that random number generator that we talked about. And then we have CCIP, which is the cross-chain interoperability protocol. Essentially, it lets you connect blockchains together. And we're going to take a little bit of a deeper look into that. I know this is like a super high-level look at all of these. If you check out our YouTube, if you check out our documentation, you want to go deeper into any of these, the resources are there. If you go to dev.chain.link, tons of places to get started there too with this. They'll hold your hands, walk you through all of this for sure. Cool. So we're going to take a little bit deeper look into CCIP. Remember, that's the cross-chain interoperability protocol. What does interoperability mean? So blockchains, phenomenal cosmic power, itty bitty living space. I know some of you are probably sad that I didn't say
Itty bitty living space.
but they also are very isolated, meaning that blockchains kind of only exist within themselves. They're in a bubble. They care about themselves and that's it, right? Like, I'm a blockchain. I don't want to see anything else. I just do my blockchain stuff and I'm happy here in blockchain land. Cool. Right. Maybe some L2s, you could argue they're like, hey, what's up, L1? Yeah, I see you over there, but I'm still over here. They are a little bit cognizant of things outside of their network. But for the most part, blockchains are very isolated. They don't talk to each other. Interoperability is a fancy way of saying they can talk to each other, right? The ability to exchange information between two different blockchains is what interoperability is. So it's the ability to communicate between the blockchains. Cool. We good so far? So cross-chain interoperability protocol, CCIP, really just means cross-chain talking to each other protocol. Interoperability comes with some weird stuff. So we're going to go like really deep into this pretty quick, but I think y'all will be okay. I mean, you dealt with those pages full of what an ERC20 and 721 is like champions. So I have faith that y'all can get through this. Blockchains have this concept of finality. Finality is basically when things are like written in stone, when that immutability happens. Okay, so that is finality. Different chains do finality differently, right? And so this is part of the, like Ethereum has one way of reaching finality. Avalanche has another way of reaching finality. Once finality is reached, though, we're at the point where no takesy backsies is how I like to think about it, right? Like we can't undo it, and we're done, right? It's written in stone. So an example, like we're talking here, some chains have instant finality. So like the minute you submit your transaction and it gets completed, boom, finality is done, no take backs. Other chains, you have to wait multiple blocks before we reach finality, right? Because sometimes they realize like, hey, 2 blocks ago, guys, we goofed something up a little bit. We need to fix it. They'll go and fix that thing, and then they reach finality. So different chains, different points at which things become immutable, written in stone. This brings a problem when you think about like, how to talk between chains, right? That interoperability piece. So when we want to have 2 chains talk to each other and agree on something, we need to kind of wait until finality has occurred, right? Because you don't want to, for example, say, if I'm a chain and who's somebody who just commented in the chat, John. John is a chain, right? And I say, so John, it looks like I sent, pick somebody else, Niels. It looks like I sent Niels $5. Cool, John? And John says, cool. On my side, you sent Niels $5. And John has instant finality. So he's like, boom, done. And I don't have instant finality. And so I say, oh wait, John, I meant $50. And Niels is over here is like, yeah, it better be $50, right? I don't know why 5, I need $50. That's going to be a problem. John, as a chain, probably should have waited for me to reach finality before he took things onto his side. So this is where like interoperability, talking between chains becomes a very big problem. or a very hard problem to solve. So figuring that out is what CCIP does, right? It solves this problem. So Chainlink CCIP gives you that tool to talk between chains, right? So we have me and we have John here in our two blockchains, A and C, and CCIP works like this. It sets up a lane, and lanes are normally set up in pairs, right? So I can talk to John and John can talk to me, right? So we've got that kind of communication going back and forth. Two-way communication is very important, but each of those paths is a separate lane, right? So like, it's basically two wires is a way to think about it, right? Like one for sending, one for receiving. So that's how CCIP is set up between chains. What can you do with CCIP? So it's like a bridge. Yes, it's like a bridge. So with CCIP, high level, the easiest way to think about it, you can send data. Everything is data. I used to be like a Unix system administrator. Unix is an operating system way back in the day. And I remember learning that a file is a stream of bytes. And all that means is like everything on your computer is just bytes. It's just data. It's just information, right? So when we're talking about sending stuff between chains, what we're talking about is sending data between chains. That can look like token transfers. And token transfers is normally kept separate. We often say that we can send tokens and data. So, keep that in mind. When you're sending tokens, you're sending a specific type of data, but we send tokens and we can send data. You can also have programmable token transfers. What that means is I'm going to send you tokens with a note attached that says, hey, do this thing. And then we can send arbitrary messages, which is just any data you want to send. So again, this is kind of a deep dive into CCIP. This is in the exam. So, pay attention. Again, we have the link to the information in Codio in the platform that we use for the exam and everything like that. So if you want to look at these slides, you have these slides available to you. It's also presented there in that platform. And so, so we have three different things that we're using here, right? We have the source chain, the destination chain, and an off chain. So these are like the three main spaces, right? When we're sending something, the off chain, that's going to be the Oracle network, right? So we go from the source chain, going to the destination chain via the Oracle network. The way this works is the sender and receiver contracts. So you have a sending contract on the source chain, a receiving contract on the destination chain. The receiver can also be an EOA. That's a weird thing. Externally owned account doesn't necessarily make it any less confusing, right? Who here has an EOA? Hopefully all of you are raising your hands. EOA is a fancy way of saying a wallet. It's an externally owned account. So when you set up your MetaMask wallet, you set up an EOA, an externally owned account. And then the way that this works is you send a message to a contract that's called a router. And that router can then send things to the token pool if you're sending tokens, or the on-ramp, which is going to the Oracle network, right? So it goes to the Oracle network, which is off-chain. Oracle network does stuff. It puts stuff on the destination chain via the commit store. So these messages are sent based on the information you passed in to the commit store. Then there is this thing called the RMN. It's the Risk Management Network. Basically, it's doing things like checking to make sure all of the information is correct, making sure like finality has been reached, that we're good. Because remember, immutable is a key piece to blockchains. So you want to make sure you're not making mistakes, right? So from here, we go to the RMN, and it blesses this contract being sent, says, yes, everything is good. It then sends a transaction to the destination chain saying, yes, everything is good. And then from there, we have the commit store and the RMN contract on the destination chain. They talk to another piece of the Dawn here that's going to actually execute this transaction. It gets those messages in. It then calls into the off-ramp contract, right? So we have a contract here, another contract here. The off-ramp router contract actually executes the transaction on that chain, and then we get our stuff to the receiver contract. That was a lot, right? We'll take a different look at it. We'll kind of follow things through here. This one moves wicked fast, but we're going to kind of follow here through this little animated thing. And if it's not showing up great on the stream, do remember you can take a look at these slides directly. I'll go ahead and just pop this into the chat again in case you want to look at this on your computer. So we have the end user, right, on the source blockchain, sender contract. That sender contract sends data and or tokens to a router contract, right? So contract, this is like what we deployed on yesterday. So that contract talks to another contract that's an on-ramp contract. It deals with the tokens if it needs to. Otherwise, it just sends information over here to the committing Don and the executing Don. So remember, Don is distributed Oracle network, so it sends it to the Chainlink stuff, the CCIP stuff. I like to just think about this as like a magical black box for ease of brain power, right? So the stuff in the middle here is the magical black box that is CCIP. But we send it to the Dons here. The risk management network checks everything, makes sure that we're good. When the risk management network says yes, green light, good to go, then the executing Don sends stuff to the off-ramp contract. If there's tokens to deal with, it deals with them. Otherwise, it sends stuff to the router contract. The router contract is connected to the receiver, gives it its data and tokens. The knee bone is connected to the thigh bone, is connected to the neck bone. End user gets the results. That's a lot. The chat got real quiet. How we feeling? If we're feeling good and this made sense, give me that thumbs up. If we're not feeling good, give me a panic emoji, whatever that is for you. My head's hurting. I don't know what this is. Is this a panic emoji or is this a good emoji? I can't tell. I think it's a panic emoji. Okay. Hopefully this makes sense. Somebody asked, what makes a blockchain able to use CCIP? Whoa, we scrolled real fast. So what makes a blockchain able to use CCIP is if everything is deployed and set up for that blockchain. That's like a non-answer. Basically, we need the router contracts there on that blockchain, and those router contracts need to be hooked up to talk to the Oracle network. Cool. If you're feeling information overload, do remember, you can back me up and listen to me again. If, like me, you'd prefer not to hear my voice, you can read this as well in the education platform. So just remember that. Hopefully it's good. But so end user, sender, sends information to the router. The router talks to the on-ramp, goes into the black box, Don stuff, CCIP, off-ramp router, back to the end user, right? Like pretty simple overall at a high level, super complex the further in you go. Okay, so I see some people saying the word use case. And it's like you saw this when I flipped to it a second ago. So use cases for this, right? Like what are oracles used for? What can they be used for? Not just for CCIP, but Chainlink oracles in general. Use cases, lending and borrowing. So like dealing with loans, getting that information from off-chain. We kind of talked about lending and borrowing a little bit with space and time as well, right? Like getting information about on-chain information, off-chain, doing stuff with it, bringing that information back on-chain. Complex computations, off-chain. Mirroring an asset, right? Say you wanted to have a real-world asset and you wanted to have an on-chain representation of that. That would be one thing that you can do with oracles. Stablecoins. This can be important as well with oracles. Say that you wanted to create, a stablecoin based on the number of random wires that you've accumulated in your house. You could have an oracle that checks the number, a proof of wire, right? Proof of reserves really is what we're talking about here. But proof of wires, and each stablecoin could represent one wire that's going to end up in the amazing wire basket that I'm pretty sure everybody has, right? Everybody has that one basket full of wires. Well, you could tokenize those wires. Asset management. So you could enable automated management of DeFi pools and stuff like that, using price feeds, using automation. Again, pretty cool. Real world use cases that are currently happening. So AWS is using Chainlink oracles for data, right? They're using data feeds, bringing that information, data streams, bringing data information on chain. Twilio is using it for notifications. Twilio is like a communications platform. They send like text messages and stuff like that. Google Cloud uses it. Meta small business uses it for NFT giveaways. Pretty cool, pretty amazing. If you go to the docs or the Dev Hub, you can see other use cases as well. And then interoperability use cases. So when we're talking about bringing in multiple chains, things like moving collateral around, governance, when you want to involve multiple chains, trading assets across chains, enterprise workflows. So when you want to bring information from one chain to another, maybe from a public chain to a private chain, as an example, stuff like that. Definitely a lot of use cases. And then this new kinds, basically, there's all sorts of new types of distributed applications being built all the time using interoperability. So with that, I know your brains are probably getting full. We're done. Congratulations. I don't know, Dave, if you want to pop back on briefly, but y'all have done it. We made it through 3 days of boot camp, but don't leave yet. There's more. Let's talk real quick about dev.chain.link, because I want to make sure that everybody gets signed up for the certification. So if you go to dev.chain.link, you head here to the Chainlink certifications. I'm just going to walk through this flow real quick one time. So you come here, you say, hey, I want to get certified. We did this. This is what we did. Blockchain fundamentals. Like you have the knowledge now. It's in your brain. We need to check and make sure you can get it out of your brain. I always joke, my brain is like a steel trap. That's right. Information goes in, but it never comes out. So we want to check and make sure that you got this stuff. So blockchain fundamentals, you click start course. It's going to say, hey, I need to sign up for an account. You can give it your name. Here, I'm just going to kind of fill this out real quick. Put your email in there. Put in an amazing password. Accept. You'll click create account. Now you can say, hey, I want to start learning. Start the course. And this is all that information that we just went through, right? All of this is what we talked about. Review. Check it out. Final exam right here at the bottom. This is what you need to do for that certification. Cool. The other thing we have is the signing up for, if you want a small group to study with, maybe chat while you're taking the exam together, make sure everything is good there. We've got a link right there for the study group. And yeah, Dave, they did it.
Amazing. Someone was just saying in chat, 85 NFTs.
85.
Go
85.
friends.
I'm proud of y'all.
Yeah.
That's awesome. There is a deadline to sign up for the small groups. I think it's November 20th at midnight Eastern time, like US Eastern time. So you got a few
12 hours.
A little bit for that. Yeah, about 12 hours. So yeah, we did it. You did it. Yeah, I don't know. I'm stoked for y'all. Congratulations. Nice work. If you have questions, Dave and I are on X. You can hit me up at the RG Dev. Dave's the Dave Dev. And yeah, my DMs are open. I check it occasionally. I'm not on there as much as I probably should be, just given the state of things in the world at the moment. For my sanity, I'm staying off X a little bit, but I'll be back on there more soon, I'm sure. But yeah, if you send me a DM with questions, concerns, cries of anxiety, whatever you got, let me know. I'll help you out. I don't know. I'm stoked that y'all stuck with this. Listen to me go on. Listen to Dave. Listen to Steven. Y'all are the real champions. It's been awesome. You're ready to take the exam. You're ready to get that certification. And yeah, I mean, there's no time like the present to just go take that exam right now while it's all still fresh. But if you want to sign up for a small group, that will be it. Yeah. This was the last of it. This is the end of it. We've reached our destination. We've made some friends along the way. It's been awesome.
It's so funny. I just think of like when my kids are growing up with the Dora the Explorer. I don't know if anyone knows that theme song. Every time you did something, you would go, "We did it." Dun, dun, dun. It always plays in my mind with "We did it." And this is so, this is so empowering. Just reading through everything that I've seen on X, I've seen some stuff come across on LinkedIn. I know for a lot of you, this was the first time. Do not take for granted what you did here the past 3 days. A lot of this is just building blocks as you go along. And we have a lot of additional building blocks on our website for you all to check out. Like there's a lot more Richard up there. I've got a video coming out on cross-chain tokens. Like there is just an incredible wealth of information for you to continue to pursue. So never underestimate your ability to learn. And once you have these skills, no one can take them away from you. You can continue to build, a better life for you and yourself. So thank you for spending some time with Richard and us. Richard, we can't do high fives now because you moved me on the side.
Oh man, hold on.
Wait, no, I can point down.
We get rid of this. It's this way. It's
Oh
this
wait,
way.
I gotta go this way now. Yeah, there we go.
Bam, we did it.
We did it.
Nice. That's what people stuck around for. All 300 of them, they stuck around for that high five. That was it. That was it. Now the number's going to drop. All right, y'all. Thank you. It's been awesome. Thanks for giving us the opportunity. Thanks for spending 6 hours with us. That's awesome.
Yeah.
Y'all are awesome. Until next time. Catch you later.